Hi students, today we are going to talk about our first chapter, reflection of light on curved surfaces or at curved surfaces. Okay, this is the first part that we are going to deal with. So before going to start the actual topic of what is the concept of this agenda of this lesson, we are going to discuss about some prerequisites that whatever we have learned in already we have learned in 8th class. Okay, so as per the name suggests, the reflection of light at curved surface. First we are going to talk about what is light. Okay, so what is light? The definition of light. So what exactly the meaning of light? Okay, see, in simple words we talk about light is a form of energy. Simple. Okay, what is light? Light is a form of energy. Okay, and there are some properties which are going to be associated with this light. That is the properties. If you talk about the properties of light, so there are two main properties that we are going to discuss about. That is, light always tends to travel in a straight path. Light always tends to travel in a straight path, and to travel and it selects shortest path to travel. So of course this we can club it and we can make it as a single statement. Okay, to make you to understand more clear, I just split that one statement into two different forms. Okay, the property of light, it is a form of energy, the definition as per the definition, and the property of light, if you talk about, it always tends to travel in a straight path. Okay, and always it select the shortest path to travel from the source of light to the particular place. Okay, so what does it mean? Light travels in a straight path. Suppose have a torch light. If I switch on the torch light, when the beam of light will go up to here, up to this extent, and it will turn again and will it reach to this place to propagate it on some object, to incidenting on some object. It's not so, right? When we switch on the torch light, all the light rays which are being emitted from this torch are going to travel in a straight path, and they are going to be projected on a object which is there on exactly straight to this torch light. Okay, that means light will not go in a curved path. It will not travel in a curved path. That is what is the main important point that we have to keep in mind. Light always tends to travel in a straight path. Always. Okay, this is the property, and this property, the combination of this light is a form of energy. It always travels in a straight path by selecting the shortest path. This property is being given by Fermat principle. We call this as Fermat principle. Light tends to select the shortest path to travel in a straight path, and in a shortest glance form, if we talk about, this is the principle of the Fermat. Now, these are the two important things that we have to keep in mind, and along with that, one more important thing of the prerequisites, the context of prerequisite, if we talk about, we are going to discuss about we're going to discuss about the definition of reflection. The definition of reflection. Okay. I have a ball, suppose for example, I have a ball and I am hitting the ball to a wall. What happens? The ball is going to bounce back into the same mirror to our side. Okay, that is the bounce, the phenomena of bouncing back of light. into the same medium. Can be considered as reflection of light. Okay, simple. In short, if you talk about the bouncing back of the phenomena of bouncing back of light is considered as a reflection of light. Okay, so what does it mean? Suppose the main source of light in our nature is the sun. Sun is the main source of light. All the light rays which are emitted from the sun are going to travel in a straight path and will reach or will strike to any object. Some objects are on the earth, and they tends to bounce back. Okay, that tendency of bouncing back of light, whenever it is going to hit to an object, that tendency or that phenomena we are calling as reflection of light. For example, assume this chalkpiece as a beam of light ray. It is going to travel in a straight path and it is going to hit to this chalkpiece. It is going to hit to this duster and it is going to bounce back. And whenever it is bouncing back to the same medium, that phenomena we are calling as reflection. Of course, this is all prerequisite we have learned in 8th class already. Just a recap. I'm making a recap to understand the concept of reflection of light on the curved surface in a good manner. Okay. I hope you understood. For example, the light ray. This is a surface. The light ray which is traveling from the source of light, and it is going to hit to any surface and it is going to bounce back. That phenomena we are going to talk about. That phenomena of bouncing back of light into the same medium is considered as reflection of light. Okay. Now there are some terminology. Terms associated with the reflection of light. The next concept is the terms of reflection. Okay, we are going to talk about the terms of reflection. There are 7 terms approximately. Okay, the first is incident ray. We are going to talk about, in short, we will talk about IR, incident ray, and we are talking about the surface. The third one is point of incidence. The fourth one is the normal. Fifth one is reflected ray. We are talking about RR. Sixth one, angle of incidence. It is angle I. And seventh one is angle of reflection. It is angle of. There are 7 terms associated with the reflection. There is incident ray, surface, point of incidence, normal, reflected ray. This is the point of incidence. Point of incidence, angle of incidence, and the angle of reflection. Okay, incident ray, surface, point of incidence, normal, reflected ray, angle of incidence, and angle of reflection. These are the 7 terms associated with the concept of reflection. So, what are the exact the sense of the incident ray? The light ray which is emitted from any source of light is considered as the incident ray. Okay, suppose if I switch on a torch light, the rays which are emitted from that torch light are considered as incident rays. Okay, I have a torch light here. Okay, all the rays which are emitted from the source of light is called as incident rays. Otherwise, I have a bulb, for example. all the rays which are emitted from the bulb are called incident rays. Or if you take the sun, all the rays which are emitted from the sun are considered as incident rays. In short, the light rays which are emitted from the source of light are considered as incident rays. Fine, I hope this you understood. Now, and in short, we use the terminology that is IR to represent the incident rays, and the surface. Coming to the concept of surface, that is the object or the plane or the anything that the incident ray is going to hit, or any object or any plane or anything that the incident ray is going to hit, that is considered as a surface. Of course, in the concept of reflection of light in a curved surface, the surface like will be the mirror, but generalized. If you talk about in general, if you talk about in general, wherever the incident ray, to which object or which material the incident ray is going to hit, that is considered as the surface. Okay, more precise, the surface will be the mirror in our discussion, to get the formation of images and to where exactly the location of image and to know the angle of incident and what is the relationship between the angle of incident and angle of reflection, there is loss of reflection. In more precise, we talk about the surface as the mirror. We consider the surface of the mirror, but in a generalized concept, the surface might be anything where the incident ray is going to hit. Fine. Okay, if we talk about the surface, that is any place or object, or more precise, that is mirror. Mirror can be considered as surface, where the incident ray with the incident ray is going to hit head. Okay, of course, the same concept we are going to use at the point of incidence also. Understand? Now, when we talk about the point of incident, the place or the point at which the incident ray is going to hit to that surface is called point of incident. For example, this is the incident ray is going to hit this surface. Okay, this is the incident ray is going to hit this surface, and at what point the incident ray is going to hit that surface? At which point the incident ray is going to hit that surface is called as the point of incident. This point, the point at which the incident ray is going to hit the surface is called point of incidence. Fine, all of you? The ray which is emitted from the source is the incident ray. Wherever the incident ray is going, the object or the material or any substance or a plane to which the incident ray is going to hit, it is considered as a surface. Upon the surface, at what point the incident ray is going to hit, that we call as the point of incidence. Is it okay? Now, what is meant by normal? Okay, to draw the normal, there are two conditions you have to keep in mind. Okay, normal is an imaginary perpendicular line. Normal is an imaginary perpendicular line drawn to the surface at the point of incidence. That means there are two conditions should be satisfied in order to draw the normal. That is, normal is an imaginary line drawn to the surface. That is, first point, it should be perpendicular. It is perpendicular to surface. The first point is it should be perpendicular to the surface. Second point, it should be at point of incidence. Okay, two conditions should be satisfied. For example, if I assume this is a normal, assume I am feeling I want to consider. Okay, see that means it should be at the point of incidence. It should be at the point of incidence, and it should be perpendicular to the surface. Okay, for example, if I draw this line, even though it is perpendicular to the surface, as it is not drawn at the point of incidence, it cannot be considered as normal. Okay, for example, if I draw this line, even though it is drawn at the point of incidence, it is not perpendicular to the surface, so it cannot be considered as normal. Where to know about the normal, it should be perpendicular to the surface. First condition, it should be perpendicular to the surface, and it should be at the point of incidence. The normal should be drawn at the point of incidence. I hope you understood. Okay, so that means this cannot be normal, this cannot be normal. Where this is a normal, where it is perpendicular to the surface, as well as it is drawn at the point of incidence. Okay, normal is an imaginary perpendicular line drawn to the surface at the point of incidence. What is the use of normal? Normal plays an important key role in order to understand so many concepts of our discussion. Of course, there are some techniques to skip the drawing of normal and all that we will discuss in our further discussion. But normal is playing key role to draw the respective reflected ray. Okay, and the ray after hitting the surface, the ray which bounces back, incident ray hits to the surface. After hitting to the surface, the ray which is bouncing back is called as reflected ray. That is we are calling as RR. Okay, that is reflected ray RR, and the angle between incident ray and normal. The angle between incident ray and normal. The angle between the incident ray and normal we are calling as angle of incidence. The angle between incident ray and normal we are calling as angle of incidence, and the angle between normal and the reflected ray we are calling as angle of reflection. The angle between normal and the reflected ray we are calling as angle of reflection, and the angle between incident ray and the normal we are calling as angle of incidence. So these are the seven terms which are associated, and we should be familiar with these seven terms to know about the terminology of. These are the seven terms which are used in the concept of explanation of the reflection. Okay. So first is incident ray, the ray which is emitted from any power source, any light source, surface to which the object is going to hit, to which the incident ray is going to hit is the surface, or the point on the surface at which the incident ray is going to hit is called as point of incident. That is normal, imaginary perpendicular line drawn to the surface at the point of incident is called as normal. To draw the normal, two conditions should be satisfied. There is it should be perpendicular to the surface, and it should be at the point of incidence. That are the two main conditions you have to take into the consideration. And the reflected ray, the ray which is bouncing back after hitting to the surface, we are calling as reflected ray. The angle between the incident ray and the normal is what calling as angle of incidence. The angle between the normal and the reflected ray we are calling as angle of reflection. Fine. These are the terms associated with the reflection of light. And one more important prerequisite. See, we didn't start our topic. We didn't start. This first part is total prerequisite about to understand the main concept of it. Okay. Next, we are going to talk about what is the terminology understood. What is the laws of reflection? Next concept is laws of reflection. There are two main laws of reflection. There are two concepts that you have to keep in mind. That is the first one. That is angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. That is angle of incidence is equal to angle of incidence is equal to angle of reflection. That is angle I is equal to angle of incidence. Angle I is equal to angle of. So what does it mean? What does it mean? So suppose there is an incident ray here. The incident ray here. We are going to draw the normal. Okay. Suppose the incident ray, the angle between the incident ray and the normal is equal is 30 degrees, for example. It's 30 degrees. With the same 30 degrees angle of reflection, the reflected ray is going to bounce back. The reflected ray is going to bounces back with the same angle of reflection is equal to 30 degrees. Fine. So if the angle of incident is 30, the angle of reflection is also will be 30. Okay. This we are calling as law of reflection. Okay. According to the law of reflection, the angle of incident, the angle I, will be is equal to angle R. Suppose there is a chance of asking you a question, if the angle of incident is equal to 45 degrees, angle I is equal to 45 degrees, then angle R is equal to question mark. Okay, so obviously we know, according to the law of reflection, if angle I is equal to 45 degrees, angle R will be obviously 45 degrees. Okay. And the second important law, I hope you understood this one. Angle of incident is equal to angle of reflection. Simple concept. So next, I've got the law of reflection. The second one is incident ray, normal and reflected ray, RR. Incident ray, normal and reflected ray, all three lies in the same plane. Same plane. So what does it mean? For example, this is not so easy, but try to understand. Okay. So incident ray is here. For example, incident ray is here on the surface of the board. The normal will be on the surface of the board, and the reflected ray will be on the surface of the board itself. Okay. For example, this is the object. This is the surface to which the incident ray is going to hit. Okay. Try to understand that. Okay. Incident ray is going to hit to this surface. Okay. This is the normal. This is the incident ray which is going to hit this surface. Normal will be obviously in the same plane, same imaginary plane. Try to understand. Okay, same imaginary plane. The normal will be here, and the reflected ray will be bouncing back here. It's not that incident ray is hitting at this plane. Reflected ray is bouncing back from this place. Okay, bouncing back from this place. It's not so. Is it fine? Incident ray is here, normal will be in the same plane, the reflected ray will be in the same plane. Okay. That means incident ray, normal and the reflected ray both are lies in the same plane, where the reflected ray cannot be coming from the next plane. This another plane, if you imagine here, it is not coming from this place. It is coming from the same plane. If you keep a paper or some plane, if you imaginary plane, if you draw here, that look like incident ray, normal and the reflected ray. All lies in the same plane. Okay, that is incident ray, normal and reflected ray. All three lies in the same plane. This is the second law in the laws of reflection. That is, first one angular is equal to angular, second one incident ray, normal and reflected ray. All three lies in the same plane. This is the law of reflection. I hope you understood this session. This is some small prerequisite of our to start our chapter, reflection of light on curved surface or at curved surface. In the next session, in part 2 also, we will continue with some prerequisites which are going to help our chapter, to understand our chapter. Then we will move on to the actual topic of our chapter after discussing some prerequisites in the next topic, next part. Okay. I hope you understood this session. Thank you and have a good day.